Todd, take it away, sir. And
Hey.
so, Todd, you're going to be doing an update on the Graviflyer, I believe.
That's correct.
Okay.
You see my screen?
Now I can. Yep. Ooh, beautiful, beautiful slideshow.
Like that one? All right. This is where we left off at the previous APEC that I spoke at. And we had already crossed off gradient forces mimicking gravitomagnetism. And we were left with aerodynamic lift from ultrasonic deformed rotor propeller. And I tried this several different ways with these thin metal discs. First of all, they have divots and pits and bumps all over them like a golf ball, which supposedly can create lift, and I didn't see anything. And then they also, I was able to use some really spongy two-way tape and get them to like flutter and buzz. It didn't create any lift, barely made it push any air. The air velocity coming off the spinning discs is about 2.5 meters per second. It's not too fast. It's not even hardly anything compared to a box fan. And I couldn't deform the disc enough to get any kind of lift out of it, and certainly not enough to really register. I did see, was it about 12 millivolts, which was a milligram, maybe a milligram of weight loss, which could be explained either that the disc started to lift up, or it could also be explained that the magnets hanging on the end of the disc started to swing outward and lift the disc because it was sagging before. And so it could just be a centrifugal force effect, but it was insignificant, nowhere near 10 newtons, which is what we want. The Helmholtz resonator. I bought some bottles, took some Christmas bulbs and made my own resonators, and they resonate really, really loud. But the speed of any kind of momentum coming out of it, is like practically nothing. It's enough to move a Christmas bulb around, but it's not enough to lift the Graviflyer. And I did not try a Helmholtz resonator with an electromagnetic field. That's still on my list. But the resonator alone is millinewtons at best of thrust from the air pressure coming out the nozzle. And so an ultrasonic resonator, I did an experiment where I put my 28 kilohertz resonator and I pointed it down at the flat plate of the scale and adjusted it for standing waves and up and down. And again, I saw maybe a millinewton of pressure being exerted on the scale due to the ultrasound waves alone, and nothing significant. And that was with an ultrasonic resonator that was drawing close to 40 watts, 36 watts. So that little piezo tweeter of Alexei's is only rated to 30 watts, and I don't think he's even putting that much into it. So that's not going to generate 10 newtons of thrust either. So the last thing on our list is an air-breathing ultrasonic resonator exerting pressure on the surrounding ionized air plasma, assisted by electromagnetic fields to accelerate the plasma at resonance. And I want to explain kind of how this works in a lighthearted way. And that's where I get the title, How to Tune Your Graviflyer. And so please stay tuned. What I'm talking about here is basically an amplified lifter. And a lot of people here, including Tim, know a lot about lifters and how they work. And a lifter basically works that the ions coming off the wire, there is enough current, electrical current of ions coming off the wire to smash into neutral air atoms, which then pass through the skirt. And as those positive ions pass through the skirt and get neutralized, it lifts the skirt and lifts the lifter. Here, it's not exactly the same process, but it's the same idea. And what you have is, let's start with the assembly. You've got 3 vertical support rods. You've got a large flat disc in the middle, and and 2 rotors. So the rotors are counter rotating. And I've found that if you have the motors close together, like I have one where I mounted both motors to the middle plate, and it's not very stable. You can't even barely feel the torque of the counter rotating motors. But when you separate them like this, and you have one up high and one down low, then they equally or somewhat equally exert a torque that can hold the thing stable. And we've all noticed how stable Alexi's Graviflyer is. So I believe that the stability is dependent upon having the motors separated as far as possible. Now, we have the spacing of the discs and the spacing of the rods. And I don't know if Charlie had given me these measurements but I recalculated them based on the drawings here, that we have about a 50 millimeter gap between the perimeter of the rotor and the vertical standoff. So about 2 inches in there. And between the rotor's disc face and the disc below it, minus any screws, we have about 1 inch or about 25 millimeters. It's a little more on the bottom one, but you have the magnets there, which kind of make up for it, but it's still a little more. Okay, so this is where we begin. Electrically, you would connect all the wires up, except you're going to connect the low voltage wires to the motors and to the ultrasound. And you're going to connect the high voltage wires to the rotors. You're not going to connect the Slayer exciter Tesla coil yet. It comes later. And then step 1, we start by adjusting the dimensions to match the drawing. That's our starting point. And then we're going to connect the jumper from the bottom disc to the middle disc. And this is because we want the middle disc to have the full voltage potential relative to the rotor. Undo that. So relative to the top rotor. The top rotor is positive, the bottom rotor is negative. Sorry, should have mentioned that. We want to apply the voltage slowly until we see a nice corona glow, or we get a high voltage discharge, a breakdown of the air, preferably between the rotor and the disc, not the rotor and the support rods. And we want to keep adjusting this until, like if we have a 30 kV supply, we want to adjust the spacing between the top rotor and the middle disc so that it's just on the verge of breakdown. And with the top rotor being positive, you should see a corona glow in the dark. And that ionized air around it should be attracted down toward the middle disk. So we're going to repeat this until we've got those conditions. Then step 3, we remove the jumper from the bottom and connect it on the top. Make sure you turn off the voltage first. Connect the jumper on the top. So now that the middle disk is positive, and we do the same thing for the bottom one, for the bottom rotor with the magnets, and we adjust it until it's just on the verge of breakdown, but it doesn't break down. And then we remove the jumper wire. Now in a dark room, we energize it and verify that you see this corona glow. If you see streamers that don't fully break down, they're kind of like just jetting off, that's a good sign, but beware. And this is really high voltage. And if you see a lot of sparks and arcing, it, as Jeremiah pointed out, that does cause Bremsstrahlung radiation. That is X-rays, can generate X-rays. And so it is dangerous when you see sparks like that. So with the high voltage applied, turn on the rotors and verify there's no breakdown. Keep your fingers crossed. If there is, adjust some spacing, give it some more room to breathe. And you don't want to break down. If you've got any sharp edges or pointy burrs or anything like that, or the hardware sticking out from the magnets, you want to cover that or smooth it out so that it doesn't break down, so you can get the maximum electric field buildup. That's what this does, is you're tuning the distances to maximize your electric field, to maximize your volts per meter without breakdown in the air. Okay, now, next step is to connect your Slayer exciter Tesla coil to the middle disk. I'm just going to say Tesla coil. The way that thing works is when the transistor pulses, the output coil goes negative. So whatever rate it pulses at, it's pulsing that disk negative, and then it rings positive. But because it's pulsing on the negative pulse, it's going to have a DC offset. Also, the way the circuit is designed is that as it gets pushed further and further DC by resonance, it's going to form its own negative DC bias in that power supply design, because there's no diode to couple it to ground. It just floats. And so that's what you're going to get, a negative bias on that middle disk that is pulsed further negative by the Tesla coil. This has the effect, and pardon my cheesy drawing, maybe somebody who can do 3D can make me a nice one, but positive ions from the positive rotor on the top will get flung outward and attracted by the negative middle disk. Negative ions getting flung outward by the negative charged disk beneath it will be repelled by the negative pulsed middle disk. So all of the ion flow around this is designed to create an ion flow downward. The electrons getting pulled off of the bottom disk, we don't want them colliding with the upper disk. We want them to move away and collide with the air around it, creating a negative ion cloud beneath it and a positive ion cloud above it, ideally, and a negative plate that rides the voltage between these two clouds. And here's where the ultrasound comes in. This thing, just by spinning it, in fact, I made a Chladni plate. Let me see if I can show you here. Okay, this is a disc that I stuck a fan on, and then the fan has an off-balance wheel. So it vibrates, and by adjusting the voltage, I can adjust the frequency of rotation, and I get a nice patterns on the disc. It's not perfect, but what I saw is, like, I was using salt, and the salt, because it's a fan, it's creating a rotary motion. It's pretty easy to get it to kind of like walk itself toward the middle and form a whirlpool in the middle. So the salt is like being walked around in the middle. But when I hit resonance, which was around, on that plate was around 1.75 kilohertz, the salt spreads out, makes a ring, a node just inside the edge, like a couple of centimeters inside from the edge of the disc. But where there isn't a node, where you've got the highest amplitude, it's kicking that salt a good inch off the top of the disc. It's just bouncing everywhere. That's what the audio frequencies do to the air around these discs. So as these discs resonate with audio frequencies, or ultrasonic frequencies, they're creating heat. They're bouncing the air around it, creating a negative air pressure, and you've got hopefully creating a negative air pressure above it and a positive pressure below it as it pushing off the negative ion cloud. And so if you've got all these conditions right, and you amplify your sound right, like a big speaker, I think it's just a matter of time before someone gets one of these things to lift off. I've done the calculations, and all you need is around a microcoulomb of charge to get forces in the tens to hundreds of newtons. So this is very interesting, and I'm still working on it. I was actually going to do the presentation in 2 weeks from now, thinking I would be further ahead, but I'm glad I could update you on where I'm at. Okay.
Wonderful. Everybody, oops, let me start my video. Let's do this. Let me see, allow participants to unmute themselves. We'll stop the screen sharing. Okay. Todd, let me put this bad boy on gallery view, and everyone please give a hand for Todd Desiato, how to tune your Graviflyer. Todd, thank you, sir. And I think you have something else coming up next week, right? Next session?
I'm working on it.
Okay. No, that's okay. That's okay.
I've updated you on where I'm at today. I've got my Schlerin viewer working. It works really well now. I haven't done anything really important with it yet. It works really good with fire, flames, big changes with that. You can see air current flow as long as it's warm. But I got a mister yesterday that's going to create some fog, and we're going to try doing it with fog, and hopefully we can change the density and see sound waves. I couldn't see anything. So
okay, well, so I'm going to take this off speaker view. Let's do